Hey, Airflow community, we've got exciting news. The annual Apache Airflow survey is live. In just 7 minutes, you can help shape the future of Airflow and grab a free Airflow 3 Fundamentals or DAG authoring certification worth $150 each. Plus, you can enter to win an exclusive workshop with Mark Lamberti. Don't miss out. The survey link is in the show notes and closes November 21st.
Hello everyone, welcome to the Data Flowcast. I'm your host, Mark Lamberti, and today I'm joined by Anja MacKenzie from Covestro. I'm super excited to have you here, but first question, how are you doing?
Thank you very much. Also, welcome to all of the listeners, and I'm doing fine, thank you. How about you?
Doing great. I'm really, looking forward to this episode because, by the way, Anja is an expert for chemical informatics, which is pretty amazing. And so today we are talking, about with Anja actually, who has taken Airflow in a completely different direction than most companies. At Covestro, a leading polymer and materials science company, she has built a simulation workflow platform that turns Airflow into a toolbox for computational chemistry experts. I mean, honestly, I'm going to stop there because this is a domain that I know nothing about. And I'm very excited again to know more about how Airflow is used in your company, because I'm sure many people wonder what you do at your company. So let's begin with some context about Covestro, like what do you do here? Can you explain what computational simulations mean in the polymer and materials science field? And then what kind of problems your simulation experts are trying to solve?
Yeah, sure. Thank you very much. So, yeah, as you said, Covestro is a company in the field of high quality polymers. So, we produce high quality polymers, and we have about 17,500 employees with operations across 46 production sites globally. So, we are quite large company, and our products are used in everyday goods like, for example, electronics, so cases of laptops or smartphone cases, but also automotive, so seats or dashboards from in the automotive industry are often including Covestro products, but we also produce products for installation, so for example in fridges or housing, or also the mattresses are often made from Covestro products, so quite diverse set of products for our products end up in. And Covestro is a very innovative company. So one of our research goals actually is to become fully circular. And for that, we are doing a lot of research. And I'm in the department which is called Digital Research of Development. And of course, we have a lot of lab scientists, but we are doing digital research and we're using digital research methods. And one of them are chemical simulations. So chemical informations you can think of are like experiments in the computer. So our lab colleagues are doing chemical experiments in the lab, and we are simulating the chemical experiments with digital methods. Typical problems would be, for example, the tailored design of new products by establishing relations between the chemical structure and also the composition of the product to the physical chemical behaviors. We can predict the physical chemical behavior of our products with our methods, but we can also investigate and simulate reaction pathways, for example, and this is used to optimize reaction conditions for our products or for the reactions that we are doing. And we can also simulate foaming. We can do foaming simulations, and we are using that to investigate the feasibility of a foaming experiment, so to say, and also to optimize manufacturing processes. So these would be typical, use cases, let's say.
So I already have so many questions, but you say so let's take an example. You said that for example in a computer I can find a product from Covestro. What will be that product exactly? Because you said products.
Yeah, yeah. So Covestro is not producing like products that directly to the consumer, but to businesses. So, for example, one of the large one of the products that we are producing are polyurethanes. And polyurethanes normally consist of so-called isocyanates and polyols, and they react to a foam. This would be a very typical example. So, for example, you buy polyol from Covestro and an isocyanate from Covestro, and they then react to a foam. And this is then
Oh,
done at our customer site. So we are providing let's say the ingredients, so the isocyanate and the polyol, and then our customer produces the foam, for example, a mattress, out of our two products. And then you have very different mechanical properties for foam. So for example, mattresses has to be very soft, but you can also imagine hard foams. And this can be then steered by the composition of the polyol mainly. So there needs to be a lot of thoughts and engineering put into our polyols, for example, to produce very certain properties of foams. And then we simulate these kind of properties and also mechanical properties sometimes to help to design the polyols and isocyanates to the needs of our customers, basically.
okay, okay, okay. So I hope that everyone is able to get that Covestro is actually everywhere. Uh, so so this is super cool. And so you mentioned that you have simulation experts that actually do simulations to ensure that everything will work out as expected. Um, can you tell us more about how those simulations are done today, or I would say actually how they were done before Airflow?
Yeah, good question. So so we have an on-premise cluster and also and there then our simulation experts typically write Bash scripts or Python scripts to run their simulations. So let's say a simulation has some components. So first of all, you have a simulation engine. Let's say, for example, you are doing a molecular dynamics simulation, then you have a very specific software tool which does this kind of simulation. But of course, you also need some setup around this. So you need to create an input file. So you need to define the simulation and also provide information about the chemical system that you want to simulate. This is part of the input file. And also you need to provide us some information about the type of simulation that you're doing and the type of property you're interested in. And this is all part of an input file. And also then you sometimes need to provide additional files, for example, describing the chemical structure or or certain properties that needs to be part of the simulation. So this is kind of the input that needs to be done. And this sometimes can be provided or can be generated by additional Python scripts and so on and so forth. So there's some kind of tool chain involved. And then after the simulation, you often analyze the results. So you take a look at, for example, a trajectory. So how did the molecule move during the simulation? You get the trajectory and then you analyze them to, for example, compute certain properties like diffusion coefficients or whatever. And this is then also another tool chain that comes behind that. And before Airflow, every simulation expert was building their own tool chain basically suited to their own needs, and they were able to run them on their environment. But this was not easily shareable to other simulation experts from the field, or maybe even other simulation experts from a slightly different field who were interested in the kind of simulation that they were doing because they needed them for their project as well. And then they were asking them, okay, can I do the simulation? And then it turned out, oh, it's not so easy to transfer the tailored script that they had to the system or to the environment that the other simulation expert had. And then this was the situation we ended up with, and we wanted to make this shareable in a very easy way to make them accessible, these kind of simulation tool chains and also knowledge that is built into this to other people from the department.
You know, it's super interesting because I don't know if you saw that on Reddit. I don't even know if you use Reddit. But there are many people wondering, like, hey, should I use Airflow? Should I use an orchestrator? And some people are saying, well, you don't need an orchestrator. I mean, you just need cron and then some Python scripts. Yes, it works until it doesn't. And that's actually a very good example. Like when you have many people working on different Python scripts, but on the same kind of bigger project, it's actually very hard to orchestrate all of those Python scripts together and also ensure that everyone is able to know what the others are doing, right? And it's just like you end up in a giant big mess with a ton of Python scripts and bash scripts or whatever that you don't even know what they are doing anymore. So it's just a nightmare. So I'm glad that now you are using Airflow, right? So tell me more about this. Like, what is your current setup with Airflow? What do you do with it typically?
Yeah, so one feature that we use of Airflow is the web UI because
Okay.
yeah, this is a very special use case. I mean, you already said that we are using Airflow in a quite different way. So all of our workflows are manually triggered. So we do not have
Okay.
we do not make use of sensors or something like this because yeah, we are triggering simulation workflows and they are always triggered by a simulation expert because there needs to be a lot of expert knowledge put into this. As I already said, each simulation workflow requires some parameters, and this is expert knowledge that needs to be put in from the respective experts. So all of them are manually triggered. And furthermore, we also have some compliance restrictions there. So like the username must be known. So we always have a user ID connected to the generated data so that we know who is the data owner, basically. Yeah, so that's why we liked Airflow, that it directly provided a web UI. And what we also really liked were the API endpoints. So this is also really, really useful to have that all of the workflows that we have on Airflow already have an API endpoint and can also be triggered by a third-party tool, let's say, which is also pretty cool. Then that the workflows are scalable is also really, really useful. And also that the possibility to customize Airflow so much is really good for us because we have a very we have very high requirements on the compute infrastructure, and this is something where we also need to have a lot of control over. So some simulation engines like to run on GPU nodes. Some of them like to run on CPU nodes, so they have a very special need on the compute infrastructure, and this is something that we also have under control. And then also that Airflow is written in Python, and that you write the DAX in Python is really, really good because most of our simulation experts know Python. As I said, most of the scripts were written in Python before, so
Right.
this is the knowledge that is already present and people are used to it, which is really good to have. And last but not least, the open source and that Airflow is open source and has a very active community is also really, really good, and is also something that we looked out for. Yeah.
Wow. I I I didn't ask before to mention all of the benefits of using Airflow, but now you know why you should use Airflow. So thank you so much, Anya, for sharing that. I guess I have quite a lot I have some questions about what you just said. But if we focus a little bit on scalability, and as you said, right, there is a lot of data. Your workloads are pretty much compute intensive. So one of the most interesting technical challenges that you solved is handling large simulation output files, right? And so sometimes I think like gigabytes. Are we talking about gigabytes of data to share
Yeah.
between your tasks? So can you explain a little bit how did you solve that in Airflow? Like how are you able to share so much data between your tasks? Because I'm sure it's it's one of the many use cases that people have and wonder what is your solution.
Yeah, thanks. Yeah, so first of all, I have to say that we are running Airflow and Kubernetes, which
Okay.
is required to know what, or yeah, it's a required knowledge for our solution. And yeah, as you said, so sometimes we have even data that is in file size of over 100 gigabytes. So it's really quite large data that sometimes get produced during the simulations. Yeah, and since we are running Airflow on Kubernetes, all of our tasks run in pods. And in principle, the data that is generated during a task run persists only for the pod's lifetime and is not shared between the tasks or the pods. And also using XCOM is not really a viable option. So yeah, we needed something else, as you already said. So what we did is that we have at the beginning and the end of the workflow or the DAG require tasks, and they create a persistent volume claim. So basically we have a persistent volume claim and a corresponding volume that persists for the duration of a DAG run. And this is then mounted to all of the pods, or the pods running the tasks into, so that they can access and share the data to the following tasks, or can access the data from the previous tasks. Yeah, this is what we came up with, and this works quite well.
Yeah, I think that's a very good solution. I mean, I think I already heard that somewhere, but it's definitely a good thing to do. I mean, definitely don't use XComs for sharing that much data. I mean, if you try, it won't work anyway. But you will end up is in some weird issues. So don't do that. Great. So can you tell me more about the Kubernetes pod operator, because it's a very common operator, used across many companies. Um, do you have like a customized version of the Kubernetes pod operator, or do you use it as it is? Right? Can you just tell me more
Yeah.
about your use case with it?
Yeah, sure. Yeah, we have a customized operator.
Ah,
So,
okay.
yeah, it's very important to us actually, because first of all, what we would like to achieve with the custom operator is that we would like to decouple the, let's say, the logic from the DAG from the infrastructure needs. So, yeah, as I said, the people that develop the workflow and then also the DAGs are simulation experts and not software scientists or software engineers. So we would like to make the life as easy as possible for them. And that's
Okay.
why we try to hide as much of the, let's say, software logic behind custom operators or yeah, custom tasks or tools that we provide to them. And yeah, so the custom operator, first of all, gets all of the, let's say, Airflow, all of the Kubernetes config from Airflow variables. So the Kubernetes infrastructure exports all of the, let's say, affinities, configs, and so on and so forth as Airflow variables, and then we can, via the custom operator, basically load them and set them correspondingly to the pods. And also the Kubernetes pod operator takes care of mounting the PVCs for the DAG run. Sometimes we also need init container, which are set in there. It sets certain environment variables for the DAG. So for example, the mount path of the PVC or of the volume is also exported as an environment variable, so that's easily accessible within the task then. And also, for example, what we often need is the dynamic setting of resources. So sometimes the person triggering the DAG also needs to have access to the resources that are used in the task, because the person, for example, the simulation expert, then know, okay, this is the quite large chemical system, so I need a lot of compute resources. And then it should be able, or the person should be able to say how much resources the task will need or the DAG run will need. And then this can be set via Jinja templating. So this is also something that we made available, let's say, during the custom operator.
No, that's cool. So it's actually you know I mean, trying to make Airflow self-service is something that many people want, because to your point, right? Like the simulation experts are not. I mean, you don't want them to be experts in Airflow,
Yeah.
and you want them to spend time in the simulations and not in the DAG authoring part. So this is cool. I mean, I'm really glad that you shared the way you use the Kubernetes pod operator. Is there any operators that you also customized, on top of your mind, that you can think of it?
Yeah. So we also modified the trigger Dacron operator,
Okay.
and for that, this is yeah, this
For
is
what?
done for, let's say, multi-scale simulation workflows.
Mhm.
So what we typically, or what we also have, is that a workflow B depend on a workflow A. So
Okay.
very often you have, let's say, tool chains in simulation tool or in the simulation workflow, where where simulation workflow A produces parameters for the simulation workflow B. And then we have a situation where each workflow or each DAG that we have in our platform can serve as a task, let's say, in another DAG, so that they are basically building blocks that we can make use of in another DAG, and then we can build even larger, more complex workflows in a very easy way. And then let's say the workflow B, which depends on workflow A, makes use of the trigger DACRON operator to trigger the DACRON A to get the parameters out of it for the following tasks within workflow B. And so by modifying the trigger DACRON operator, we try to make also this as smooth as possible for the people developing these kind of workflows. And what the modified version, for example, does is handling over or passing over the information about the PVC, because then the workflow A also need access to the PVC from workflow B. and also pass the user ID of the trigger user to the workflow, so that also the data generated there knows from which person it stems, or it was created basically. These are typical modifications that we made there.
That's cool. That's really cool. That's the first time that I hear about modifying the trigger diagonal operator to pass the PVC that you use between the tags. So it's an interesting use case. So you just mentioned about customizing operators, but do you customize anything else in Airflow in order to make the life of simulation experts easier?
So we also modified the web interface via
Oh, okay.
plugins.
How so?
So for example, one feature that we needed was the upload of files. So as I already said in the beginning, an input to a simulation workflow can also include a file input. So for example, a file describing molecular structures, or molecular systems or larger systems, for example. And these need to be uploaded at some point because you cannot have them as a normal parameter, right? So it's quite difficult. And for that, we have created a new, let's say, endpoint, a new Flask view for uploading files, where the front end, for the front end, we use DropZone for the file upload. And then on the back end, we accept the files from Python Flask. And then if it's a chunk file, we are combining the chunks together again. And then we have an own PVC and, of course, associated volume for the uploaded files, where they are then stored. And they are also stored like on a user basis, so every user can only see their own files, so
Okay.
that they cannot have access to files from other users, of course. And then this upload volume is also mounted to the respective pods where the task run into when they needed to access uploaded files, for example. This is something that we've modified in the web interface.
That proves something else about Airflow is how customizable it is. Because to your point, I mean, you can customize let's say the building blocks of your data pipelines, but you can also customize the user interface. And for those who don't know that, in Airflow 3.1 now you can go one step further because you have this React-based plugin mechanism. So now your plugins can be in React, and so you can pretty much do whatever you want now with the UI. And so again, if you want to make Airflow as easy as possible for your teams and ensure that the Airflow user interface fits with your needs, then again, you just need to create your plugin or whatever, and you can customize whichever part of Airflow. And again, you just shared that right now, which is really cool. Before closing our amazing episode, I have one question for you that wasn't planned actually, but can you tell me more about the if you have any advices for new users of Airflow, right? Like someone that wants to use Airflow, but it's the first time. Do you have any advices to share about that?
Yeah, so I have to say, when I started with Airflow, I took your Udemy courses, which were really, really great.
Thank you so much. I just said that this question was not scheduled. Okay.
But
okay.
it's the truth. Also, this is something I share with all of the people who started with Airflow in our department. I always say, take a look at Udemy courses because they're really great. I also have to say that I really like the astronomer tutorials and the sources on the astronomer website. From my side, I found the documentation on Airflow itself, so on the Airflow website, not so, let's say, easy to read or easy to see what's going on there. I really liked the content provided by Astronomer, which is also not scripted, let's say. So these were two resources that I heavily used and also shared within the team. Yeah.
Okay, no, that's cool. That's cool. Yeah. I mean, I think the point here is Airflow might be a bit difficult at first, or maybe a bit overwhelming because you can do many things with it. But as long as you have the right resources, it will be always pretty easy to get started with Airflow. I mean, obviously, if you use Kubernetes, it might be a different story, but you know that Kubernetes is pretty hard. Great. again, like, thank you so much for joining. One last question to you, Anja. What is the best way for folks to get in touch with you? Do you have a LinkedIn
Yeah,
or something?
yeah, exactly. So via LinkedIn or via my company mail. So anja.mackenzie@covestro.com or via LinkedIn. Maybe you can also put this in the show notes
Yeah,
or so. Cool.
yeah.
Yeah, and
What is the we just put Anja MacKenzie and then we find you on LinkedIn?
I hope so, yes. Never
Oh,
done
okay,
it.
okay.
But
I mean, I find
I think
myself, I was able to find you, but I think
okay,
that.
that's good, yeah. So I hope it works. I think I can also give you the URL maybe to the LinkedIn that's listed under my LinkedIn profile. Then it should work, I guess.
That's
Yeah.
perfect. Okay.
Yeah, cool. Yeah, and also I want to say thank you very much for having me. It was really, really great to be part of this podcast, and I really, really enjoyed it.
Awesome. Well, thank you so much, Anja. It was a pleasure to have you in this episode as well. And who knows, maybe we will see you again for another one. So thank you so
Yeah,
much for doing well.
pretty good.
Take care. See
Yeah, see you. Bye bye.
you.